Now, we're standardizing our test statistic, which is really telling us how many standard errors our statistic is from the null hypothesis. So when we do our z-score, it tells us the standard deviations, but remember we're dealing with our distribution, so it's our standard error, because standard error is the standard deviation of your distribution. So our z-score is calculating the standard errors that our statistic is away from our null hypothesis. And it really puts everything on a common scale so we can figure out how extreme or not extreme our statistic is. So if this statistic is normally distributed, then we can go ahead and look at our p-values. Our p-values, the area underneath your normal curve that is beyond that test statistic. So when we go back to our firstborn, if they're smarter than the non-firstborns, remember we had a difference in our means being 30.26 and we had a standard error being 37. Well, our test statistic would be our 30.26 minus our null, because remember we're assuming that there is no difference, so when you subtract two things that are the same because there's no difference, you get 0 over your standard error, and you get a z-score of 0.818. Then we could go ahead and go to normal distribution on StatKey. We want to do our right tail because we're thinking they're smarter, so it's greater than. Type in 0.18, and then we get our p-value being what we have right here, 0.270. So for confidence intervals, remember, it's your statistic plus or minus that z star times your standard error. And we looked at z stars for 90, 95, and 99%. You could actually do it for any others if you wanted through the normal distribution on StatKey. So your statistic, remember, comes from your normal or original data. This comes from your normal distribution on StatKey, and this standard error comes from your bootstrap distribution. For p-values, you do your statistic minus your null over your standard error. In other words, you're figuring out your z-score, so that comes from your original data. That's your null hypothesis, and once again, this comes from your randomization distribution. And then we can compare or calculate our p-value. So wouldn't it be nice to be able to figure out that standard error without doing those thousands and thousands of simulations, either for your bootstrap or for your randomized distribution? Well, we can, and that's what we'll be doing in the next chapter.